Now, if you were wanting to do this without just graphically, this is a great one to do graphically because the circle is going to make a picture. And you know, usually Desmos gets really angry about typing in things with an equal, but circles are kind of the exception. To get things that have an x and a y on the same side to graph correctly, it is going to make you put the equals 0. So sometimes, you know, it gets mad if you do have the equal 0. This time it got mad if you didn't. And we'll go ahead and make this big. And what it wants to know is the radius. Well, you can probably look at it and count that the radius is 2, but just in case you get stuck, it usually either gives you a left-right max or a up-down max. So in this case, it gave you an up-down max, so the diameter would be 4, because from 4 to 0 would be 4. From 4 to 0 would be 4, so that means the radius is 2. Very easy to do with no algebra. Let's go ahead and try the next one. On number 27, it says it's an isosceles trapezoid. Well, if it's going to talk about an isosceles trapezoid, I'm going to want to see an isosceles trapezoid. And it says bases are 16 and 26. And then the sides are 13. So that's 13, and this is 13. And then it wants to, it tells you the flooring material, basically wants to know how many it takes. Well, you need to know the area of this thing. You may remember formula for area of a trapezoid, but that's not one that sticks with me too well, so it might not stick with you. So what you can do is you can drop down little right triangles there, and basically if the top piece is 16, this is 16, and that means 26 minus 16 is 10 left over, so there must be 5 here and 5 here. Now you are going to need this height. So to get this height right here, I'm going to use Pythagorean Theorem. So my height squared, you could have just called it x if you wanted, plus 5 squared should be equal to 13 squared. So time to pull up Desmos again. 13 squared minus 5 squared, because I have to get everything on one side. Oops. And that's 144. So if the height squared is 144, I guess that means that the height is the square root of 144, or 12. So h squared comes out to be 144. So the height is 12. Now at this point, I still don't have the area, but I'm getting close. So we're going to go a piece at a time. We're going to start with this rectangle in the middle. It would be 12 times 16. So I might as well keep Desmos handy, I guess. Let's see, 12 times 16 is 192. So that's 192 in there. And then I'm going to do this right triangle over here. And remember, area of a right triangle, it's basically half of a rectangle. So it's 1/2 the base times the height. So it's going to be 1/2 5 times 12, which in this case, 5 times 12 is 60. Half of that is 30. This triangle is 30. Since it's isosceles, these triangles are equal. So that's 30. So my answer is that my area is 192 plus a pair of 30s, which is an area of 252. Now, it says each piece of material is 2.5 square feet. So if I have 252, to get your final answer, you'll do 252 divided by 2.5. So we'll go ahead and do that. I'm going to get rid of that. It keeps getting in my way. So I said 252 divided by 2.5 is 100.8, which means you're going to need to buy 101 pieces. You don't want that 0.8 of a piece missing from the edge of your wall or something. It looked kind of tacky. Okay, next one. A random sample. Random sample means everybody's equally likely to get chosen. If you only pick the people from brown hair, that's not very random. That's not very equally likely. People raising the most funds, not very equally likely. Selecting from a hat, that makes everybody equally likely, so that's a good random sample. The last ones to arrive, that's not a representative of everybody. You might have people more responsible than that or less busy than that. So you got 28 should be C. On this one, this is talking about margin of error. And the good news about margin of error on your exam is they will give you the formula. So it's basically just a matter of plugging into the formula they give you. And in the formula, it tells you S is standard deviation. So the standard deviation is this. And n is the sample size, and the sample size is 75. It's not the total number of people there, it's the number of people you pick. So, it's the number of people you pick. So to do your margin of error, we'll pull up Desmos again. We'll see if we can do the trick to make it show up on the side. So here we go. I can do 2, and then times my standard deviation, which it said was 0.4, divided by the square root of n, and once again you can pull it up or type in SQURT, and then that gives you the margin of error is about 0.09. So that is correct. The margin of error is about 0.09. Now there's several of, this is one of the ones where you have to, there might be more than one correct statement. I'm pretty sure the margin of error can't be 2 different numbers. So know that this first one is not right, the second one is, and now these two are kind of opposite, so one of them has to be right and one of them has to be wrong probably. So it says margin of error would decrease if the sample size was changed to 125. Well, let's just see what happens. If you change to 125, the margin of error did go down, so that would decrease, so that's a correct statement, meaning it did not increase, so the statements that are correct are the second and the third. So that's one where you might have to pick more than one statement. Not too bad. And it is a general thing, since you're dividing by the square root of your sample size, the bigger your sample size gets, the smaller your margin of error can get, because if you divide by bigger numbers, your answer gets smaller. Now, last one, I got a police chief is taking a random sample. There's a mean and standard deviation, and he wants to decrease the margin of error of his next sample. So the margin of error is this. They gave you the formula again, and it says, what would you do to decrease your margin of error? Well, basically, you would want to, we just said you would want to increase your sample size to decrease your margin of error. If you forgot that so quickly, or maybe you know the last problem wasn't margin of error before on your exam, let's go ahead and look about how you could get Desmos to help you with this. I could try typing in the formula in Desmos. And it asks for sliders, so I say, sure, I like sliders. And now what you can do is the standard deviation, you know, was 2.5. And now that gives me margin of error of 5. And then you just say, well, what happens if I were to increase the sample size? You can see the margin of error decreases as you increase the sample size, and you can see it will increase as you decrease the sample size. So that's a way you can use Desmos and the slider, especially when asked questions about what happens if this increases or decreases. You can always set it up that way. Hope these lessons helped you understand things on the exam. If you have individual questions, please reach out and let me know. I'll be happy to help you in any way I can.